So in your previous session, I discussed about OSPF, about initially we have started about disadvantages of RIP, link state protocol, OSPF characteristics, and OSPF router ID. You know, OSPF router ID, first preferences for router ID command, second preferences for highest loopback IP configured in router, and third preference is highest physical interface IP address. And OSPF neighbor states, OSPF neighbor 7 states. Neighbor down, neighbor initial, neighbor two-way, start, exchange, loading state, and full state. 7 states and OSP of hello packet contains and what is the adjacency, hello packet parameters we have seen, wildcard mask, OSP of tables, and OSP of configuration. So today, let me continue with OSP of metric. If you make a heading, OSP of metric. So OSP of metric is cost. The cost formula is generally 10 power 8 by bandwidth, right? So that formula you can write like this. Reference bandwidth by interface bandwidth. Reference bandwidth by interface bandwidth. Yes, this is the formula we use for OSP of cost calculation. By default, difference bandwidth is 100 Mbps. So that is what? Reference bandwidth means what? 10 power 8 by bandwidth. The same formula you can write like this. So by default, difference bandwidth is 100 Mbps. Default reference bandwidth is 100 Mbps. Now we got a reference bandwidth. Now interface bandwidth. So what interfaces generally we use in the network? Can use Ethernet port, fast Ethernet. If it's Ethernet, speed is 10 Mbps. Fast Ethernet and serial port, you know. Fast Ethernet port speed is 100 Mbps. Serial. So generally these interfaces were used to configure. So we know that Ethernet port speed is 10 Mbps. Fast Ethernet is 100 Mbps. What about serial interface? So serial interface default bandwidth is what? Let me check here. Show interface. Fast Ethernet 0/0. Enter. Then here you can get bandwidth showing kilobits. If you convert into megabits, it's 100 Mbps. The same command for serial also. Any interface, same command. Show interface, serial 0/0. Bandwidth is 1544 kilobits. So 1544 kilobit means if you convert into megabits, it's 1.5 Mbps. So serial interface speed is 1.54 Mbps. Right? So now we got reference bandwidth and we know interface bandwidth also. Let me implement the formula of cost. For Ethernet, cost is the reference bandwidth is 100 Mbps by interface bandwidth is 10, 100 by 10. Then what is the cost of Ethernet port? 10 is the cost. Right. Fast Ethernet. The reference is 100 Mbps. Interface is 100 Mbps. And cost of fast Ethernet port is 1.
1.
Reference bandwidth is 100 Mbps by interface bandwidth is 1.54 Mbps. So cost of serial port is 64. You can get the value. We calculate it. 64. So these are our default OSPF cost values. It's clear?
Balu, in this case, we are using any Giga Ethernet bit, matlab, 1 Gbps. Then the formula is also same?
Yeah, same formula. Good question. So in this case, what if we use gigabit Ethernet? Ethernet, fast Ethernet, gigabit Ethernet. Reference bandwidth is 100 Mbps by interface bandwidth for gigabit is what? 1000 Mbps. Then what's the cost of gigabit Ethernet? 100 by 1000. Yes, what is the formula here? 100 by 1000 is, we can get cost is 0.1, right? From point values. So we cannot consider point values as a cost. So even gigabit Ethernet cost is 1, same. Point values we cannot consider. Okay. Like this. All WAN links are connected. Serial links. Serial S00, S01, R1 to R3, S01 and 00. LAN ports are fast Ethernet ports. R1 LAN is FE. R2 R2 is a fast Ethernet. Let's consider R3 is a Ethernet 0/. Ethernet port. Tell me guys, what is the cost of fast Ethernet port? OSPF cost, fast Ethernet OSPF cost.
1.
100.
1.
100.
R2 fast Ethernet 1. R3 LAN port is Ethernet. What is the cost?
10.
10. The remaining all are WAN links. R1 to R2 WAN link. So WAN interface, serial interface cost is what default? 64.
64.
64.
64.
64. Now in this topology, let me implement OSPF protocol now. Say R2 network is 10.0.0 network. Let me configure OSPF in all three routers. Anyone can please help me out to configure OSPF? OSPF configurations, please. These are the directly connected networks.
Config D.
Okay.
Root. OSPF.
Yeah. Process ID can use any number. 1, 2, 3 now. Network space network ID. 172.16 network. Next.
255.
That's wildcard mask.
Wildcard mask.
What will be the wildcard
Yeah,
mask?
0. 0 dot.
Yeah,
0.
0.0.
255. 250.
255.255 and default area ID
0.
0. Next network is 18 dot network.
18.
My God, sorry. It's actually
70.
172. Config 176. Let's remove this 176 command.
No network.
Yeah.
Network 192.
Right.
What?
So 172.16, 172.18, and LAN network is a network 192 dot 168 dot
168.
1.0 0.0
250.
255 area
Area.
0. Like in router 2, 3 directly connected networks. Router OSPF cross ID 10.0.0.0 wildcard mask. Wildcard mask is 10.0.255.255.255 area 0. 172.17.00 0.0.255.255 area 0 and 16. Then we'll get one neighbor is active between R1 to R2 neighbor. Yeah. R3. Default area ID is 0. .network. Again, we'll get one more neighbor is active. From 9.2.168.2.0.0.0.0.255 area 0.
You missed the one more network.
Yeah. What is that?
172.18.
18.
Yeah.
Yes. Now the neighbor is up. Actually, instead of 18, I have configured 16.
Yeah.
Yes. So now in the 3 routers, we have configured OSPF. The scenario is from R1 to R2. From R1 LAN to R2, how many paths we have? Like traffic can go via S0/0 to R2 network, or S0/1 to R3, R3 to R2. So 2 exit points via S0/0 or via S0/1. So what is the cost? What is the total cost from via S0/0 to reach 10 dot network? What is the total cost?
64.
Total cost from S0/0 to reach 10 dot LAN.
132.
Yeah, it's shortest distance R1 to R2 S/S00 S01, right?
Yeah, see, S0/0, S0/1, there are 2 paths are available. So via S0/0 traffic is going to reach a 10 dot network. What is the total cost? S0/0 link, the WAN link is 64 and traffic come to fast Ethernet port of R2. R2 fast Ethernet cost is what? 1. So 64 plus 1 to reach a destination. What is the cost value total?
65.
65. Okay. Now what about via S0/1? If traffic is going S0/1 to reach the same destination, what is the total cost?
129.
129.
129.
9.
9.
9. So 64 plus 1. That's 129. So which is the best cost?
65.
65. So that information will update in the routing table. Let me check clearly. Show IP route. So to reach standard network, OSPF updated, 110 AD value, 65 is a metric. The best metric is 65. The next stop is 172.16 and via S/0. You're reaching to standard network via metric is cost is 65. So what if S0/0 is down? Your BISTRIT is being failed, then what information you can get? Now traffic is going via S0/0 because of is a best path, best cost. Now what if S0/0 is down? Then immediately traffic can go via S0/1.
S01.
Yes, let me make wantonly 0/0 is down. Interface serial S0/0 it's shut down.
Shutdown.
Now if we check routing table once again, show IP route. So how to reach standard network? Are you showing the information now? So whenever S0/0 is down, same network, entire network, 110. Oh, it is not copied, I think so. So now metric is 129, right? Metric is a 129. Yes. So S0/0 is a down and same network, AD value 110 and cost is 129 as we have discussed. Traffic is going via S0/1. Exit point is S0/1. The cost is 129. Next stop is this one. So this is how exactly we can understand these cost values. These are the default cost values. However, we can change the cost values also based upon your link bandwidth. We can change. So example, this WAN link is by default is 64 and I have configured manually cost is 128 have changed. 128. Now tell me the cost of via S0/0. So via S0/0 cost is what? 129 plus 1.
129.
Yeah, 128 plus 1 is 129. So via S0/1 is also 129. Now to reach the 10 network, the two paths is a two paths same cost, then which is the best path?
Load balancing.
Load balancing. So both interfaces will come into your routing table. So I'll show you how to change the cost values. First, let me make this link is up. Now let me show you how to change the cost. On which interface we have to change the cost?
0/0.
R1 serial 0/0. Right. In R1 serial 0/0. So interface serial 0/0. IP OSPF cost 128. So serial 0/0 default cost is 64, but forcefully wanted we have configured cost is 128. Now if we check the routing table, show IP route. So to reach standard network, 129, 129. So traffic is going by S00, S0/1, both. Load balancing. Means both entries is available in routing table. Means what? Load balancing. Okay. So these are about OSPF metric calculation. Any doubts about OSPF metric?
Follow?
Yes.
If you want some percentage of traffic to go on one route and a percentage on other route, can it be done?
Yeah, equally load balancing OSPF, but like as you asked, like a percentage of WAN link means we need to do manual again.
Okay.
OSPF packet and types we'll discuss. We'll discuss about OSPF packets. Between the two routers, how the neighbor relation will be formed? How neighbor will be formed between the two routers?
Hello.
Hello packet. So hello packet is used for to discover the neighbor, to maintain the neighbor. It's a keep alive mechanism. How many seconds hello packet?
30
10
10
seconds.
seconds. OSPF for 10 seconds, right? Yeah. So this is OSPF. The first packet is hello packet. I'm listing here OSPF packet types. This is very important for interviews. OSPF packet types. Hello packet. What is the purpose of the OSPF hello packet?
Maintaining a neighborhood.
So first, initially, it can discover the neighbor, right?
Yeah.
Yes. OSPF is to discover the neighbor by using hello packet and to maintain the neighbor also hello packet. So once neighbor is being formed, then what routers will do? Once neighbor is in established between A to B, then what routers will do? Extend the database. Information is have to exchange, right?
Sending routing tables.
So to extend the database, they have used packet called DBD packet. Database description. Hello packet for neighbor forming. DBD packet for database details. Okay, database is exchanged. Now OSPF supports incremental updates. When there is a change in topology, then only update. So here I have configured OSPF. It's been 10 minutes. The network is established. It's been 10 minutes. No changes. Then no updates. It's been 20 minutes. Network is established in OSPF. No changes. No updates. It's been 30 minutes. No changes. It's actually no updates, but OSPF for every 30 minutes, additionally, all routers will refresh the database tables. Refreshed. So it's been 10 minutes. Let me check my database table, your database table, same or not. Like they're going to refresh the action, you know. So when it's going to refreshing, now A will send one message. So router B, do you have any new updates? For that, it uses packet call LSR packet. Link state request is asking for link state request. If B has any updates, we'll send it LSU link state update. And A will send the information thanks, like link state acknowledgement. So these all are OSPF packet types. Hello packet, database, DBD packet, LSR, LSU, and LSACK. So link is nothing but router interface. State is description of interface and neighbor relation. Neighbor routers, sending to neighbor routers. LSAs are additionally refreshed for every 30 minutes. OSPF packet types. Hello packet. To discover the neighbor. To form the neighbor relation is a keep alive mechanism for every 10 seconds. DBD packet. Database description, update or exchanged. LSR, which is link state request, used for requesting for new updated information. LSU, link state update, receiving the updated information from the neighbor. And acknowledgement, link state acknowledgement, so sending thanks for information, called link state acknowledgement. So these all are OSPF packet and packet types. Okay. Right. So can use this command show IP protocol for hello and didn't timers to verify OSPF hello packets, debug IP OSPF hello. Now let's see OSPF area concept. What is the areas? Area concept is OSPF supports unlimited hop count, right? So means in real time we use OSPF for very large networks. If you take example of any one large network in the banking sectors, see the large network in banking sectors. Any one example?
SBI.
Okay, SBI. How many branches in all over India wide? Let's consider there are 10,000 branches. So where exactly these 10,000 branches been located? In only one city, like all over India wide? India wide. So we have, I'm going to categorize the different categories, like your main office and head office 1, head office 2, head office 3, head office 4, like head offices. Your main office is connected to head offices. Head office 1, head office 2, the head office 3. The branches, branch offices. This is branch 1, say branch 2, branch 3, branch 4, or branch 5, like all branches. Number of branches. All branches are connected to head office. Yes. This all the routers comes under one area, means one group. So number of routers comes under one group called area. Area means not a physical area, it's a logical boundary. So number of routers comes under one group called area. So how many routers in this picture now? There are 10,000 routers, is it? So all 10,000 routers comes under one area. So what is the default area? Area 0. So now this all routers comes under area 0, guys. How many routers? 10,000 routers. Okay. So what we have discussed about link state routing protocol? Remember link state routing protocol. The first point, every router maintains full picture of the topology. In OSPF, every router should maintain what? Full picture of the topology. That is a rule. So here, every router should maintain full picture of the topology. Okay. Main point is Cisco routers has different type of categories. So Cisco differentiated majorly 3 categories: branch router, network edge router, service provider router. Remember, in introduction to router we have discussed. Yes. Yeah. But tell me one model number of branch router. So branch routers are 2800 series, 2611 like this. The head office router says 5000 series or 5500 series. These all are head office routers. Okay. The main office ISP type of router 9000 series. It's a hierarchy design. Now what is OSPF telling is every router maintains full picture of the topology. So in topology, how many routers is it? 10,000 routers. So main office router has to be maintained 10,000 routers links information, and head office also has to be maintained. Your branch office also has to be maintained. Your head office router and your main office 9000 series routers, they have a very high-end core processor, high capability, high speed routers. They can maintain, they can manage. But what about your branch routers? So branch routers don't have that much capability to maintain such large networks. If still it is maintain the 10,000 routers links information, your all branch router performance is going to slow down. Problem. You know what all branch routers is doing is sending automatically generating the message to head office. We are running out of memory. The routing table is too big. These are problems in OSPF single area. These all routers comes under one area. Additioning the branch routers. So branch routers, I'm running out of memory because my routing table is too big. Because of it is 2600 series routers. So 2600 routers don't have much capability. There is a very low processing speed, low internal storage. That is why these routers are recommended to use for branch offices, for small networks. But if we use OSPF, what OSPF is telling is that every router should maintain full picture of the topology. In topology, you have a 10,000 routers. So even your 2600 router also has to be maintained 10,000 routers links information. And then problem is this, running out of memory because my routing table is too big. So these information is generating to head office routers. Branch 1 is sending, branch 2 is sending, branch 2, like all branches is sending continuously messages to head office routers. What is the message running out of memory? Routing table is too big. So it means head office routers is receiving too many times. So I'm receiving too many times, too many LSAs. See, your branch routers are busy and head office routers is busy. But branch routers are busy to sending a messages and head office routers are busy to receiving a messages. And what head office will do will update to her main office. Then what main office will understand? Okay, I have to run again algorithm. Too many times is running algorithm. So it seems a complete topology, all 10,000 routers are busy. Then how user traffic can be forwarding? This is very big problem in the OSPF. So to overcome this type of issues, OSPF is designed, divided into single area into multiple areas. So OSPF network design is divided into multiple areas. One area has to be designated as area 0. It's divided multiple areas. Like few routers comes under one area. Again, some few routers comes in another area. Again, some few routers comes in another area. And you can define the name for areas. Number is area 0 is default. We can start with area 1, area 2, area 3 like this. For example, area 10, area 20, area 30. But what is the logic here? One area has to be designated as what? Area 0. So area 0 must be there. So let me dedicated area 0 is this. Main office is area 0. Area 0. So this area 0 we call backbone area. Backbone area. So after areas is designed, then what is the advantage of these areas? Now in area 10, how many routers is it? branch 1, branch 2, branch 3. 3 routers, right? As per this diagram, 3 routers. Now, once if his areas is being configured, now branch 1 no need to be maintained 10,000 routers links information. Within the area routers information only can be maintained. So within the area means branch 1 router has to maintain branch 2 networks and branch 3 networks. That's it. So now routing table is very minimum is become. Before it has to maintain 10,000 routers links information. Now only 2 routers. Then performance is good. So this is why to minimize the routing table in OSPF areas is designed and to improve the network performance. So here we have designed in area 10, branch 1, branch 2, 3 routers only, right? But generally each area recommended is 30 to 40 routers we can use it. For each area, recommended is 30 to 40 routers. Okay. So area 0 is called backbone area. Why it is a backbone area? So backbone area means area 10 users, area 10 routers, they can communicate. Why? Because within the area they maintain the network's information. Now what about area 10, area 20? How area 10 routers, area 20 routers can talk each other, can communicate each other? Backbone area. So area 10 want to communicate, the traffic has to go via backbone area. Like any areas, any non-backbone areas, area 10, 20, 30, like any non-backbone areas want to communicate. So traffic has to go via backbone area. That is why we call this area 0, we call this backbone area. The remaining all are non-backbone areas. Okay. Now here, OSPF router roles I'm telling here. Router which belongs to area 0. So area 0 routers we call BR, backbone routers, BR. Okay. Now, a router which belongs to regular areas or non-backbone area means area 10 routers, area 20 router, area 30 routers. These all routers are, we call it is IR, internal routers. IR, internal router. Okay. Now, what about head office routers? The head office routers belongs to which area? The head office is a area 10 or area 0. So routers which belongs to two different areas. See, head office route is connecting area 10 to area 0. So router which connecting to different areas, this router we call ABR, area border router. Router which belongs to different areas, connecting to different router areas. This is ABR, area border router. Clear? So these all are OSPF router roles. BR, backbone router, IR, internal router, ABR, area border router. So BR is backbone router, belongs to backbone area, which is area 0 routers. Internal router, router which belongs to non-backbone area are regular area routers. ABR, which connecting to different areas. Is ABR. So here have an example. R1, R2, and R3, three routers. R1, I'm running RIP protocol. In R2, if I configured OSPF protocol, R1, R2 will communicate? Yes or no?
No.
No. Because of different protocols. RIP algorithm is different. RIP will send the multicast with 224.009. But OSP will understand 5. Both are different mechanisms, both are different algorithms. They don't communicate actually. Right? Now, if I configured RIP in R2, now R1, R2 will communicate? Yes.
That's right.
Yes.
Now, in R3, if I configured OSPF, router 3, I'm running OSPF. Now, R3, R2 can communicate?
No.
No.
If I configured OSPF in R2 now,
Yes. Yes.
so I'm running the two protocols in R2, OSPF and RIP. Now, R1, R2 can communicate, yes, with what? RIP protocol.
RIP.
R2, R3 can communicate with what? OSPF,
OSPF.
right? But my question is, R1, R3 can communicate?
No.
No. Exactly.
Different protocols.
Because of different protocols. But still, if you want to enable communication, RIP want to communicate the OSPF, then we have to do something in router 2, which is redistribution. If we configure redistribution, you know what is the redistribution is doing is going to exchange the routing protocols, different protocols. So RIP routes is coming to router 2. What router 2 will do? Will redistribute with OSPF networks. Whatever advertised by RIP networks, that RIP networks is being converted to OSPF in terms of OSPF and send it to R3. Then R3 can communicate. Now, when R3 is sending a networks, that OSPF networks is being converted to RIP networks and advertised to RIP. So there is a mechanism. Like you want to migrate the protocol from RIP to OSPF, then the best solution is what? Redistribution. Okay. So instead of completely changing of OSPF here, let we continue with the RIP protocol, existing protocol. Then do redistribution. It can be complicated. Now, what exactly router 2 is doing now here? So router 2 is connecting different protocols, is enable communication between two different protocols, right? So this router we call, wherever if we configure redistribution, so that router we call ASBR, Autonomous System Boundary Router, ASBR. ASBR, Autonomous System Boundary Router, two different protocols configuration. Two protocols enable communication. So these all are OSPF routers. BR, IR, ABR, ASBR. Okay. You can see this diagram. Area 0 routers are BR.
Right?
Yeah.
We can use any router for redistribution, right?
Yes, you can use any router. But that router should be configured both protocols, OSPF and RIP. Both have to be run.
Okay. If we are using two protocols, then we can use redistribution,
Exactly.
right? Okay.
Yes. So types of routers. Backbone router, which belongs to backbone area, is backbone router. Which belongs to regular area, internal router. which shares two different areas, ABR. Router which is connected to different protocols, ASBR. Okay. So it's all about OSPF. It's about OSPF in LAN type of networks. OSPF, we configured OSPF in LAN type of technologies. Means all routers are in ISP switch. I see the branch 1 router, branch 2, branch 3. So generally, branch offices we use for what? Lease line, right? Point-to-point connectivities. But these all the branches within a city only. Within a city. Then within a city, then we can have very high speed links, very high speed connectivities with these metro Ethernet types of links. If metro Ethernet means ISP will give connectivities to LAN ports from ISP switch. From ISP switch, they'll give the cables to router 1 to fast Ethernet, router 2, when the LAN ports. All routers are connected to via LAN ports. They basically all are connected to serial ports, right? Not here LAN ports because of you are using what? Metro Ethernet type of connectivities. Here R1, R2, R3, R4, R5. Like all are connected to LAN ports, fast Ethernet ports, to ISP switch. So this type of topology we call BMA topology, broadcast multi-access. So what is the problem in BMA topology is BMA network. Let's consider router 1 IP address is 10.1. It's 10.2, 10.3, 10.4, and 10.5. For R1, router A is connected with serial 0. So first tell me the neighbor relations for all routers, please. Let me start with router A. For A router, which one is a neighbor router?
R1.
For A, R1 is a neighbor. Okay. For R1, which is the neighbor router?
R2, R4.
For R1, which is the neighbor router?
R2.
R4.
Router A is a neighbor,
A.
and see R1 is connected to switch, ISP switch, right? If it is connected to switch means all are directly connected. So for R1, router 2 is the neighbor, router 3 is the neighbor, router 4 is the neighbor, router 5 is the neighbor. So for R1, R2, R3, R4, R5 the neighbors. For R2 neighbor, please. For R2. R1, R3, 4, 5.
4, 5.
For R3, R1, 2, 4, 5. For R4, R1, 2, 3, 5. For R5, R1, 2, 3, 4 is the neighbor relations. OSPF behavior, any changes in the network topology, it has to be updated the neighbors, right? After some time, route A S0 is down. Route A S0 is down. Has some change. Now what R1 will do? Okay, we have one modify in one of my neighbor. So that information have to update to my neighbors are R2, R3, R4, R5. So that information R1 is going to update to R2, R3, R4 and R5. So what all routers will do now? So router 2 will look into, okay, I got one update, so I have to update to my neighbors. You look into neighbor table, like R1 is the neighbor, 3 is the neighbor, 4 is the neighbor, 5 is the neighbor. So what R2 will do now? Now again R2 will send update to all routers. Now what R3 will do? Update to all routers. R4 update to all routers. R5 like all routers will start sending update. So that is where broadcast is being happened in this topology. Bandwidth is wastage. Router performance is going to making down. Unwanted bandwidth, unwanted traffic. Why? Because of all routers are sending updating. So to overcome this type of issue, OSPF is designed. No, don't update all the neighbors. Any one router has to be updated here. In this OSPF LAN, at present all routers are neighbor, right? Okay, neighbor is okay, but update has to be sent in only one router. So that router we call it is a DR, designated router. So DR has to be sending updates to all routers if any changes in the topology. Then which is the DR in this topology? Router with highest priority, OSPF highest priority will become the DR. Router which has a highest OSPF priority is DR. Now what if priority is the same for all routers? So router 1 priority is 1, router 2 priority is 1, router 3, router 4, router 5, like all routers priority is 1. Then which is the DR? So whenever priority is the same for routers, now OSPF will consider highest router IP address. Highest IP address. So 10.1, 10.2, 10.3, 4, 5. This is the highest IP, 10.5. So router 5 is become the DR because of highest router ID. So any changes in the network, DR has to be updated, not all routers. Designated router. Okay, problem is solved. So in OSPF, when you configure OSPF in LAN type of technologies, in Metro Ethernet type of technologies, we require DR to send updates. If it's a point-to-point network, then DR is not it. Not it. Clear? Any doubts here?
Balu, here the doubt is that, for example, R1 neighbor A router was down. So that information now router 5 has to update to all routers,
Yes.
not router 1.
Yes. So if link is down for R1, then you know what R1 will do? R1 will not send updates to all routers. Why? DR is there in network, right? So any router, any changes, that router has to be updated to DR. So wherever change is there, that we call initial router. So initial router will update to DR. Now what DR will do? So that information, whatever update coming from the initial router, that information DR will send to all neighbors. Like this. Okay. So any changes in topology, which router has to be updated? DR. Now what if DR fails?
Second highest.
Yeah, that's why what OSPF is doing is pre-calculated one more DR.
BDR.
Exactly, which is BDR. Backup designated router, DR and BDR. So DR is a highest priority will be DR and second highest priority will be BDR. If priority is the same, highest router ID will be the DR and second highest router ID will be BDR. So which is not DR and which is not BDR. See, router 5 is a DR, router 4 is a BDR, right? Now what about R1, R2, R3? So which is not DR, which is not BDR, remaining all routers we call DR others. DR others. So initial DR others will update to DR and DR will update to remaining all routers. Now OSPF multicast IP address, whenever DR updating to DR others, DR to DR others, it will use 224.0.0.5.
5.
When DR others is updating to DR, we'll use 224.0.0.6 multicast. DR to others 5, others to DR is 6. Okay. So these DRB elections will happen automatically based upon the priority and route ID. Priority you want to change, you can change. Like forcefully if you want to make router 2 is a DR, then configure highest priority here. Then router 2 will become the DR.
Priority is cost, is it?
Priority is?
Is it cost or what is priority?
No. The value you have to define. Cost is different, priority is different. Priority value.
Okay.
Sir, why they are using 224.0.6 or 224.0.5?
5 for DR to DR others update. DR others to DR update is 6.
Why not other figure use?
Different.
Other IP address, these are results.
Yes.
5 and 6 are results. See, there is no logic like a why you are using 5 and 6. Why not 7 and 8? It's just
Okay.
the developer used 5 and 6.
Okay.
Yeah. So OSPF priority, you want to change, we can change. You want to make any router as a DR, then you can change. Like interface fast Ethernet 0/0. IP OSPF priority. Highest priority is 255. For example, 180 have configured. What is the default priority is 1. Default is 1. Then router 2 have configured 180. So router 2 will become the DR now because of highest priority. Like we can change the priority.
Balu, I have a doubt, Balu.
Yes, please.
You were telling previously that one router can be used as for both protocols.
Yeah.
That can be RIP and OSPF can run on the same router.
Yeah.
Can the serial port also be configured for both OSP and RIP?
On serial interface, we are not configuring. We are configuring the protocols and under router mode, right?
Okay, you are countering. Yeah. For the router, you are configuring.
Yes.
Okay, got it. Yeah.
So this is a OSPF in LAN, which is BMA topology, DR and BDR election process. It's clear? Yeah.
Show the diagram.
This.
So up to now, explain
Well, what is
that
BMA broadcast?
Broadcast multi-access.
in this topology, if R2 is down, so R5 is the DR, so it will send all the updates from R5 only, you know.
Yeah.
If in this topology shown that A is down, completely A without A is shown, or with example including A. Router A.
Any changes?
In this topology,
Completely
if
A is
R1,
down or link is down also. Any changes? R will update to DR.
okay, if R1 is down, but A is not directly connected to DR, no, then how it can send that?
Yeah, if
R1
R1 is down, then what DR will do? Okay, in our topology, one of DR other is down. So R5 will update to R1 is down information.
Okay, even it is not directly connected to A also, it can send the updates.
Like any, why it is directly connected now? R5 is a part of a switch, R1 is a part of a switch.
Okay.
See, for R5, which is the neighbor, R1 is the neighbor, R2 is the neighbor, 3 is the neighbor, 4 is the neighbor. If R1 is down, then what R5 will do? I mean, DR will do update to all routers.
I'm asking about router A. For router A, it can also send, no?
If router A is down, then R will update to DR.
Okay.
It's
A
not
is
connected
down
with
and R1 is also down. A is down, then R1 is also down. Then R5 will update only R1 is down. If R1
not
down
A.
means after R1 everything is down. Okay? Yeah, you can ask me now.
Yeah, same doubt, Balu.
Okay. It's clear?
Yeah.
Right.
My doubt, Balu.
Yes, please.
In the previous picture that you showed for that bank, where we have the tree type of
Yeah.
diagram that you showed. In this diagram, how can we implement priority?
So here, no DR and BDR.
In this
DR,
topology, there
yeah.
is no BDR and DDR.
That is what? No DR and BDR here. So DR and BDR concept will come in OSPF in LAN type of technologies, LAN type of connectivities only. If it's a
Okay.
point-to-point connectivities, DR and BDR is not required. No need.
Okay.
Yeah.
Okay.
So because of why here DR BDR required means there is a possibility of broadcast here. For R1, all routers are the neighbors. So for R2, again, all the routers are the neighbors. So one update packet is continuously broadcasting here actually. So that is why to overcome that, we require the DR to update. So
Can
that
you
is
give
what
some
happens. Yeah.
Can you give some practical examples in the real life who use this uh, metro Ethernet type of
See,
connectivity and who
almost,
use that
almost
tree?
like, see, example, I used to work for the police intelligence department. So they are
Okay.
using
Okay. And in this, how are you dividing areas? There is no concept of area. Everything will
no
come into
concept of
diagram.
area here. No concept of area here.
Okay.
Default area is 0. So that is what? Two types of OSPF networks. One is point-to-point. Point-to-point network. The best example point-to-point network is lease lines and BMA network. This example of BMA network is Metro Ethernet type of links. For point-to-point network, DR and BDR is not required. Why point-to-point? How point-to-point networks are connected? R1 is connected to R2. That's it.
So MPLS also will come into point to point.
MPLS is NBMA, non-broadcast multi-access.
Okay.
It is connected to like a OSPF in LAN similarly, but is non-broadcast. NBMA. It's a multi-access only, but non-broadcast. So here R1, R2. So for R1, R2 is the neighbor. That's it. So R1 have any changes? Update to R2. R2 any changes? Update to R1. So it's a single neighbor. What about in here in Metro Ethernet? There are multiple neighbor relations. Then DR and BDR is required. Okay.
In previous example also multiple area networks is there, right? Bank
Multiple
example.
areas, not multiple neighbors.
Okay.
If we have the multiple neighbors, then problem. Multiple areas is no issues now. But neighbor relation is only one neighbor, single neighbor.
Okay.
Yeah.
Wherever multiple neighbors is there we have to use
Exactly. You got the
Okay.
point. Wherever
Yeah.
multiple neighbors is been possible, then we require a DR and BDR.
Okay. Got it.
Yeah. So that is why when you're connected to OSPF with the LAN ports, then multiple neighbors will come actually. If we connect to the WAN ports, serial ports, lease a line, then no DR, BDR concept. Okay. So these are all the points we have finally have completed.
Balu, can we connect to the gigabit port in that?
Yes, Nishan?
Can we connect in the gigabit port?
Yes, of course. Any port, Ethernet or fast Ethernet or gigabit or 10 gig, whatever, like Ethernet port. Not only fast Ethernet, any type of LAN port, I think. Of course, in the real time, we used to connect the gigabit port only. Yeah. Can you please check the list? So we have completed OSPF. Link state protocol, OSPF characteristics, router ID, 7 state, neighbor, and hello packet parameters, wildcard mask configuration, OSPF 3 tables, metric calculations today we have started, and OSPF packet types and single area, multiple area, router types, BR, ABR, internal ASBR, and OSPF and LAN, which is BMA topology, DR and BDR. So we have completed about OSPF. Any doubts?
Balu, one doubt.
Yes, please.
In recent example, you show that SBH network is there, no?
Yeah.
Yeah, between area to area.
Yes.
For this, we don't record any DR and BDR.
No need.
But in area, we can use, no? In area there is a
Yeah, within area, if we
you
have
can use
a BMA network, there DR will come.
okay, in area 10 we can use the DR and BDR, no?
Yes, exactly.
Between B1, B2, B3.
If you have the type of connectivities, then you can use
Okay.
it. Okay. Dynamic routing in IGP have three protocols, which is distance vector protocol, link state protocol, advanced distance vector protocol. So we discussed about RIP and OSPF clearly we have discussed and EASR. Actually, we have the OSPF to understand. I have explained the RIP also. We'll do one thing. We'll try to compare the three routing protocols. So I'm not going to the detail of EASRP, just overview about EASRP. Yeah. Distance vector, RIP. RIP stands for S. RIP stands, please.
Routing interface.
Routing information protocol.
Interface protocol.
Information protocol, right? Yes. Good. It's an open standard. What do you mean open standard?
Applicable for all routers.
It can support for multiple vendors.
Yes.
Bellman-Ford algorithm. What do you mean by classless routing protocol?
Don't support submitting.
It support for subnetting. Yeah. And metric of RIP is hop count. Based upon the hop count, find the best path. Maximum is 15. Multicast address is 24009. Updates are periodically.
Periodic.
And update timers are 30 seconds. Invalid is 180. Flash is 240. But the good thing is it supports for load balancing when for equal hop counts. And administrative distance is 120. So these are the points about RIP protocol. Now let's compare to OSPF. Link state routing protocol. OSPF stands
Open standard protocol.
open shortest path
Fast.
first. Exactly. So open shortest path first, and it is also open standard. Means multiple vendors. SPF algorithm, classless, support for subnetting. Metric of OSPF is cost. So today we clearly discussed about how to calculate the cost calculations, and maximum hop count is unlimited. And when OSPF we use 5 and when you use OSPF 6, 5 and 6 multicast address, please.
It's DR and BD.
DR to DR others is 5.
Okay.
DR.
And DR others to DR is 6.
Very good, very good.
But Balu, in normal scenario, this multicast is not used OSPF.
We'll use it.
Which IP it will use?
5.
Default is 5.
Default is 5. Updates are incremental. When there is a change, then only update. Hello timers are 10, 40, load balancing. When load balancing equal cost, it is 10. So now compared to RIP and OSPF, which protocol has more advantages?
OSPF.
OSPF. Now let me compare with next protocol is advanced distance vector protocol, which is EAGRP. Enhanced interior gateway routing protocol is also open standard, but it was Cisco. Like in before 2013, is a working only Cisco devices, Cisco routers. Algorithm is dual algorithm. The main point is also classless routing protocol, support for subnetting, and metric of RIP, OSPF, and EHRP you look into here. So RIP metric is what? Hop count only. OSPF metric is what? only cast. But EHRP metric is composite metric. It can consider 5 parameters. It check the bandwidth of the link. It check load on the link. Check delay. How much delay on the link. Reliability of the link. And packet size MTU. So EHRP consider 5 parameters. 5 K values. I repeat. Metric is of EHRP is composite metric. The metric parameters are, the one is bandwidth, load, delay, reliability, and MTU. The advantage. Maximum hop count is 255 and multicast address is 224.0.0.10. 9 for RIP, 10 is EHR. Same like incremental also can support. Thing is, compared to RIP, OSPF fast protocol. But compared to OSPF, EHRP is very fast protocol. Not only compared to OSPF, compared to all dynamic loading protocols, EHRP is a very fastest protocol. Like protocol conversation is very fast. So within 5 seconds, neighbor has been discovered. Within 50 seconds, neighbor has been down. Invalid neighbor. Okay. And OSPF will do, EHRP will do load balancing. OSP will support load balancing. RIP supports load balancing. Like all protocols support for load balancing. Please tell me when RIP will do load balancing?
Equal.
When RIP will do load balancing?
Equal half count.
Equal hop count. Okay. When OSP will do load balancing?
Then metric
Cost.
cost 10.
Cost is equal. But EHRP protocol, only the protocol can support equal and unequal cost load balancing both. So EHRP supports equal and unequal. So unequal links also we can share the data. So before someone is asked in one link some percentage of data, in another link some percentage of data you want to share, then you have to use EHRP. EHRP can support for that actually. Okay.
But I hear that many data centers only use OSPF, and why?
Yeah, good question. So compared to RIP, OSPF is more advantageous. Compared to OSPF, EHRP is more advantageous. Then most of these cases in the real time, still we are using OSPF only. Why? So because of EHRP, it was Cisco proprietary. Before 2013 is a works in only Cisco. So before 2013, which protocol is the best? OSPF. So already all data centers and all IT companies is being enable OSPF. So they are existing topology, they are enable what? OSPF. So the team, the engineers are very expertise in the OSPF protocols. So they are continuing the OSPF only. If the new existing topology, then go for EHR. That's the reason.
Okay.
Yeah. So this is a 3 protocol comparison.
Can you
And
please send that text to
yes.
note per note? Can you send this note now? Comparison note.
Yeah, comparison. I'll share the chart. Okay. See, one important point I'm skipping from the last few days. That is administrative distance 120, 110, 90. Remember the values? For static routing AD value, remember?
One.
One.
So what is this exactly, this administrative distance, how it works, when it works? This is our network topology and first link speed is 10 Mbps. Second link speed is 70 Mbps. Next link speed is it's 90 Mbps. Now here A2H scenario. In A router, if I configure static routing, as per static routing, out of 3 routes, which is the best path?
Maybe.
Why ABH? Why ABH?
It's two hopping system for
So means
ABH.
static routing will find the best path based upon the hops.
When it is dynamic. But,
No, we have to define the static routing.
It is configurable.
Static routing is configured by admin. We have to define that, right?
Yes.
We have to define all path.
Yeah. So as per static routing, as per network admin, let's consider 0/1 is the best. 70 Mbps. This is my best route. Maybe it's my secure, it's way faster, something. So as per static routing, let's consider 0/1 is best route. Okay. The same router, if I configure RIP protocol, then which is the best one?
ABH.
ABH.
Why?
It's based on the hop count.
Based on the hop count, RIP will find the best path. So 0/0 is the best. The same router A, if I configured OSPF, then which is the best path?
ADFGH.
Via S0/2. Why? OS will find the best path based upon the bandwidth, 90 Mbps. So in one router, have configured multiple routing protocols. Static is enabled, RIP is enabled, and OSPF. Now from LAN users, traffic is being generated. These LAN users want to reach to H. The traffic is coming to A. In A, multiple routing protocols is running. So what static routing is telling is that, so A, you send the traffic via S0/1, this is my best path. The same time, no, you send the traffic via S0/0, RIP will tell that, because it's my best route, shortest route. OSPF, no, you send via traffic like this, has a good bandwidth. So 3 protocols is telling the 3 different routes. Then A will use which one? A has been confused. So how A will trust which is giving the best information? How A will trust it now? So in this type of scenarios, A will trust the protocol based upon administrative distance. Static routing AD value is 1, RIP is 120, OSPF is 110. Administrative distance is reliability of the protocol or ranking of the protocol. Lesser AD value, higher the priority. So which protocol has less AD value, that protocol has high priority. So now in this scenario, which protocol works here? I mean, which method of routing will work? Static.
Static.
AD value is 1. Okay. So administrative distance is reliability of the protocol, less AD value, high priority. Clear? Have administrative distance, protocol, okay. Yes. Static is 1, RIP 120, OSPF is 110, EAHRP is 90. So, any doubts? about AD value?
Well, in this same topology, now if I using the RIP protocol, other than A remaining routers, I enable the RIP protocol.
Yeah.
So in this case, my LAN is connected to the D port, and if I communicate it to the B router LAN,
Okay.
can communicate, na?
Yes, can communicate. See, before one scenario we discussed. Yeah, this here. In R1, which protocol is running? RIP. R3, which protocol is running? OSPF. In R2, which protocol is configured? OSPF and RIP. So out of two protocols, which protocol works here?
I can based on the AD value.
Yeah, in R2, we have configured OSPF, we have configured RIP. Two protocols is running, right? Now, when you have running the multiple protocols, which protocol work here? OSPF or RIP? Or both?
AD count will count.
Okay, AD is 110. AD is 120. Which protocol work?
ESBR.
Obviously, between R2 and R3, it should work OSPF only. When
OSPF.
going to the R1, it should convert to RIP.
So in
No, it will go in.
R2,
It will go in R1 RIP only. It should go in RIP only.
no, actually in R2, both protocol works in this scenario. Because of R2, R1 can work with the RIP. R2, R3 can work with the OSPF. So in R2, both protocols is working. You know, when administrative distance will come in the picture is, if we configure OSPF in R1, if we configure RIP in R3, in R1, two protocols, in R2, two protocols, R3, two protocols. Now which protocol works?
AD.
Now AD will come in the picture. So OSPF will communicate. Okay. Yeah. So this is all about dynamic routing protocol. So successfully we have completed dynamic routing and
Balu, how to remove this protocols? I enabled RIP in one router and I want to remove the
no router, array, no router OSPF with process ID.
Okay.
You can remove RIP also, you can remove OSPF also.
It will completely remove and no need to remove network wise. Once I remove.
Completely remove. Network wise is not required.
Okay.
You have a 10 networks advertised. Any one network you want to remove, then you can go for under router mode, then you can use it.
Yeah.
Router RIP. Then only one network you have to remove, they can use no network, so on selected network. 10012 you have to remove. Then only 1.0 is removed.
Balu, one more question in more doubt in this OSPF cost count. See, if normally when we have done the metric calculation,
Yeah.
so if you are taking gigabit Ethernet and as well as fast Ethernet as a one.
Okay.
In that case, for example, one route is working with 1 gig and other route is working with 100 MB. So those
Okay.
case, what will happen by OSPF?
Good question. Very good question. Tell me the cost values. 10 Mbps cost, please. 10. 10 Mbps link cost is 10. 100 Mbps cost is what?
1.
1. 1000 Mbps cost?
That is also calculated as 1.
1.
1.
Fast Ethernet cost?
1.
1. So via S0, how to reach R4 LAN? Destination is 10 dot network. What is the total cost value?
11. 12.
10, 1, 1. What is the total cost value?
12.
12. Via S1, what is the total cost value?
That is also 12.
So what OSPF will do if the cost is equal?
Load balance.
Load balance. So means traffic is going via S0 also, traffic is going via S1 also. But R1 to R2 with 10 Mbps, okay. R1 to R3 with 10 Mbps, okay. But R2 to R4 is 100 Mbps and R3 to R4 is 1000 Mbps. So some packets you can go very fastly, some packets have the delay. Problem is it. So cost wise is same, but bandwidth is wide. What's the difference is now? Why cost wise same? Because of gigabit Ethernet cost is 1. So in these scenarios, we have to change the formula. Reference bandwidth by interface bandwidth. What is the default reference bandwidth? 100. The default reference bandwidth had to change as a 1000 by 1000. Then get 1. Reference bandwidth is 1000, right? And interface bandwidth is what? 100. Then 10. So cost will be changed if we change the formulas. Here will be 10, is a 1, is a 100, it's a 100. Is a 10. Once if we change the reference bandwidth. If you have a gigabit port, then you have to change the reference bandwidth. Now via S0/S0, what is the cost value now? 120, right? 120. Via S01,
11.
which is the best one? Traffic will go via 111, like this. So when we have a gigabit type of links in the network, the formula we have to change, which is default reference bandwidth, have to be changed.
This will be changed automatically, or we have to, as administrator, we
We
have
have
to
to
do this?
configure, we have to change.
Okay.
Yeah.
Thanks, Balu.
Right.
I have a question, Bala.
Yes, please.
So in routing and switching, entirely you're talking about, there are only these 3 protocols which will be working on RIP, OSPF and EIGRP, or you probably have in the real world?
No, mostly in BGP also will be work actually. No RIP and no RIP actually. OSPF, EHRP, BGP is the main protocols in real world.
BGP, okay.
Yes.
It is also open standard.
Yeah, BGP is open standard protocol. For different autonomous systems to connect, we use the BGP. So the backbone of internet service providers protocol is BGP.
So these all probably will come in CCNP, is it?
Yeah, in CCNP, BGP, the main core subject of CCNP is BGP. No,
Okay.
only for BGP we have 3-4 sessions will be there.
Okay.
So there are a lot of things to discuss in BGP. BGP metric is attributes, lot of metrics. Which metrics is it? BGP will not support for load balancing. They don't compromise. If you have equal bandwidth, they don't compromise actually. It go for another parameter. So BGP is not designed for load balancing. It's only for autonomous system to extend the routing protocols.
Okay. Thank you.
You're not starting STP?
Yeah, and LAN technologies will give the STP protocol. We are in routing part now, right? Once we'll discuss about LAN technologies, within a LAN, the loop will be formed. So when you have the multiple links, loop will be formed. There we'll discuss about STP protocol. Probably like Monday, Tuesday,
Okay.
yeah, after 3 days, we'll discuss about it. All right, so we have completed successfully about routing part and the dynamic routing, and tomorrow freshly we'll start LAN technologies, introduction to LAN technologies. Thank you. Have a nice day.